Hello everybody, my name is Desmark and this is my floor. And today I just wanted to talk to you about Bailey Mark II. So this is Bailey Mark II. It doesn't look as nice as Bailey Mark I because this was made in 4 months during school. And this was made in like 3 weeks in school for a project. I just used these designs and made them much better for my school project. But let me just talk to you about it. It's pretty cool. So let me just talk to you about Bailey Mark 1. It's looking kind of weird right now. Like it looks like it's falling apart because it is falling apart. Just look at it, bro. Look at this length standoff right here. And let me just show you something. This fell from 10 feet. You can see the cracks right here. It broke. Look at the standoff hanging out of nowhere. Like, yo, I can literally break this right now if I wanted to. But I spent too much time on this, you know? I have when you spend a lot of time on something, you don't want to take it apart. But I'm probably gonna have a video taking this apart. I gotta milk these YouTube videos, you know? So let me just talk about this robot for a second. Since I forgot, some of you might not watch my videos, and this robot was designed to be controlled by this Xbox controller, which is pretty cool. And I actually got it working with the Xbox controller. Just watch my previous videos if you haven't seen it. I'm kind of too lazy to show the demonstration again, and the robot's kind of broken, so like, yo, go watch those other videos. But I want to talk about this guy right now. So the improvement I made is that, like, that robot had 3 power supplies. 3, and I worked on it for 4 months, so I don't know what I was thinking. Like, I was on something, bro. Like, I had, like, look at the power supplies. Look at the power supplies. This is a holder for one of the power supplies to power the Raspberry Pi. 2 and 3. This third one is used to power a goddamn fan. I could have just used this. Or it could have been. I could have just used this as one power supply. But the benefits of using 3 were that this robot could last for like a long time. Let's just talk to you about this robot, which its fancy dancy is. It isn't as clean. Isn't as clean, but it's more advanced. Like, as you can see, there's like an IR sensor. So like when I drop a part into here, it can see if there's a part, and there's like some line sensors. You know, line sensors and IR sensors are the same thing, bro. Like, the only difference is that line trackers, you just take an analog value. Like this, I just take a digital value. And if you don't know what I'm talking about, like, yo, analog has a range of numbers. Like, for example, 0 to like whatever number. But digital, yo, there's only 2 numbers that you can get. 0 or 1, or on and off, or true or false. I think if you took electronics course, or if you haven't, you probably know this. If you took electronics course or electrical course ever. So let me just turn on this robot and show you what's going on. I just gotta make sure I don't put my hand in front of here because I programmed something. I'll probably show you a clip later. So this is my robot. And let me show you this LED. Like, it's pretty cool. Like, when I do not put my hand in front of the robot, this light turns on. But when I put my hand in front of, when I put a part into the robot, it'll run the program. I'll probably show you a demonstration of it later on because, yo, this thing's gonna go mental. Because, like, I don't have any green tape, and it looks for green tape in my program. So, yeah. So, when there's part, when there isn't a part, then, like, this light turns on. When there is a part, this light turns on. And, yeah, this whole mechanism uses, like, a linear actuator. Like, it's basically a motor that's been designed to, for forward motion instead of spinny motion, you know? Like, it doesn't, like, go like this, it goes like this. That's how it works. So, yeah, this is my robot. I'm calling it Bailey Mark II. It's much more advanced. It's taller than the original, you know, like, by 1.5 times, which is, like, pretty good. Like, yo, I spent 3 weeks, 4 months. Difference. I know the wiring's kind of length, you know, like, yo, look at the wiring. Like, it's all over the place. But, yo, I did this in a day. Bro, I made the program in goddamn 2 days. Yo, when I was assembling this, I'm probably going to have a bunch of pictures showing the assembly process. I literally assembled this in a week. Bro, you don't know how hard it was to assemble this. And when I built this, guess what happened? There's a reason why I have this tail. I want to call this thing Perry the Platypus because, like, you got, like, a beak in the front and then you got a tail in the back. If only it had, like, some yellow filament, yo, it would complete the color style. Then this tail would be good. But this thing will literally tip like this. And for a project that's worth a lot, yo, if my robot tips, yo, I'm not going to get a good mark. Instead, I just was like, you know, I like had an extra part. Like, this part I used to use for this. But then I, like, redesigned it, like, shaved it in half. So I didn't need this part. And since I designed everything to fit anywhere, literally anywhere. You could put this here, you could put this there, you could put this here. I literally designed it like that. So, conveniently, these holes lined up. And I was able to connect pretty cleanly, you know? Like, pretty clean. So, like, instead of this going like, boom, I'm gonna go die. It just goes like this. Oh, rip, I turned on the program. Rip. Gotta turn this robot off. Yeah, this uses an Arduino instead of a Raspberry Pi to turn on. I did that because, yo, I'm not spending more money on a Raspberry Pi. You know how much it costs, bro? I'm a broke. Raspberry Pis cost, like, goddamn, like, I think, like, $100, like, $150, bro. Like, yo, I'm not gonna spend more than, like, I'm not gonna buy more than one Arduino yet, bro. I'm not making no YouTube money yet. Like, yo. Oh, yeah. That's enough rambling. I should explain to you what this is using. So, it's using, like, an L290 motor driver, which, like, controls the motors and everything. And if you're going to use one of these, yo, make sure you have a 12-volt power supply. Because if you have all this crazy stuff going on, yo, like, it's not going to work. And then you're like, why is my chassis not working? Why is it not working? Because you didn't check the goddamn specifications. This can work on 9 volts. This can even work on 6 volts. But if you're running anything besides the chassis, this won't work. This is some advice, guys. Just look at the data sheets. Look at the goddamn specifications. Because if you don't, you will have problems. And yeah, I just took my old chassis design and just, you can see the inspiration. I literally took this, I took this, made it taller, and I made this and designed a new mechanism. And when I show you the clips and stuff, like, you're gonna see how I made this and the journey it took. Like, yo, I'm gonna show you it right now, dog. Like, yo, it's coming up right now. Okay, guys, I just forgot to talk about one thing. Like, so I'm gonna have the demonstration wait for a while, so I can explain to you that, like, all the wiring is literally on this breadboard. Yeah, the breadboard. It's been zip tied and everything so the wires can't go up. Yes, I'm a mad lad and the breadboard's upside down, bro. Like, yo, don't even mess with me. So, like, yeah, I also have a relay. So this relay controls the LEDs and the linear actuator right here. So this is a linear actuator, goes in and out. And yeah, I'm gonna show you the demonstration, but before that, I'm gonna show you the journey of, like, what it took to make this robot. So let's get into it, guys. Let's get it. So let me just talk to you about the journey. Like, with all great things, it started with the CAD. This is what actually made it possible for me to make this in 3 weeks, because I spent a week perfecting this design. And let me just tell you something. This CAD isn't perfect. Literally, the robot's almost 3 times as tall as it's supposed to be. It's actually meant to be a little bit at the same size as the original Bailey Mark 1. But, like, when you start building stuff, the CAD always changes. I don't know. In my experience, it's always been like this. So, yeah. After I was done the CAD, I literally moved my printer to the garage because I started grinding the printer, you know. I started making print for 2 days straight. And when those prints were done, I started assembling it. And, like, this is what you're seeing right now. You're seeing my assembly work right now and the process. And what's on my bread right now is the assembled product, which is pretty cool. So, guys, after I assembled the parts, yo, I put my Arduino on the table and I started wiring, bro. The wiring was pretty good. Like, let me just show you what it looks like. I started, like, doing that clean wiring, bro. The pictures are gonna come up right now. That's clean, bro. I started going off, bro. I started making clean wiring. You can see that loop-de-loop on the Arduino. But I soon realized that this clean wiring had consequences. Consequences of this is that stuff didn't work. So, like, what I had to do is start doing messy wiring, you know, like, had to do this messy wiring to actually start doing the test. And, like, let me just show you a video of those tests right now. Like, yo, let's do it. Test of actuator opening up. Yep, it's working. It's working. It's pretty slow, but it's running off of one battery. Pretty good, yo. Pretty good. As you heard from my past self, like, that test went pretty good, but, like, this test went even better. The chassis was working, everything was perfect. Like, I was pretty happy. Like, as you're gonna see, the wiring was pretty messy, like, really messy, because, like, I am doing a lot for this robot, so, like, the wiring's obviously gonna be messy, but, like, as you're gonna see, like, I'm gonna show you pictures of when I started making it more clean, you know? When I started making the breadboard look clean, I focused on the breadboard because it was critical because it distributed the power throughout my whole robot, so I had to make sure it was clean. Like, I had to make sure I put the nice wires in there, made sure the wires were all good, tested them with a multimeter, put zip ties all over the place as you see here, and then eventually the robot started coming together. Like, I slowly put it together, put the wires, duct tape, electrical tape, put the robot upside down so I could actually assemble it because it was a pain, and then it was together. I was happy, but I made a critical mistake in the design and I had to redesign it. Dun dun dun. Okay, yeah, at this time, bro, I was stressing on my mind, bro. I had like double the amount of exams than courses, bro. I was stressing, bro. I didn't even sleep for the whole month of April because my course load was crazy, bro. I had 6 courses in a semester, almost like double the amount of exams, and I worked 24 hours per week. So like I had to start trying to engineer a solution quick because it's getting into crunch time. There's a week of school left. I have to finish this. So I hit the CADing software and I start modifying stuff. Like as you see, that's the top part of my robot. What I did is that I literally like started throwing screws all over the place, quickly CADed something so I could fit my 12-volt battery holder. By the way, I actually did order it on Amazon. But yeah, because like as I said in multiple times, look at the goddamn schematic. Because it was because of the schematic that this robot didn't work. But now it worked, everything was fine. Yo, I was happy. I started the program, and yeah, this is what the robot looks like. And as you can see, it has a tail because it would tip. Okay, it's finally time to show you like my robot. Like, let me just explain what I'm gonna do. I'm gonna place a part and I'm gonna show you my program. So like I'm gonna do it like pretty soon, like 3, 2, 1. I'm gonna do it. Like this robot takes some time to compute, so like let me just give it like a couple seconds. Give it a couple seconds. And I think it should start pretty soon. Yeah, it turns around, it basically looks for a green line, and then it drops the part when it sees a green line. So it goes straight till it sees a green line, and it knows something's green because of the color sensors, and then it drops the part and then goes back. And as you can see, is you probably noticed the LED switching because it knew that the part was in there. But yeah, let me just be honest with you guys. Like, let me just be honest. I had like a very little time. Like, this was like a couple days before like school was over. Like, it was on Wednesday, bro. Friday school was gonna be over, bro. I want to hand this in. I wanted to hand this in early. So what I did was I literally put green tape all over the room and made my programming as easy as possible. And I did pretty good. The end of the video. Thanks for watching, and I appreciate how you guys spent the time and watched my complete video, and have a wonderful day. Bye.